So they give us the graph of f of x, and now we're going to find out what do negatives do. Okay? The first one we're going to look at what happens when there's a negative, and I'm going to say that negative is outside of the function. Does that make sense? Okay? Now, so far, everything that's been outside the function has affected y and has affected things vertically. And you can connect negatives, like that's a parabola. Do you remember what happens when you had a negative outside of a parabola in grade 11? Negative x squared, what did that do? Made it open down, right? Basically took it and flipped it over the x-axis. So the same thing happens with all functions. If you have a negative out front, your graph is going to get flipped over the x-axis. So what we're going to do right beside this, you have some space. We're going to write the following information about, oops, I wanted to do that 1 second. Well, I can still do that 1 second. Here we go. A negative on the outside. Come on. There we go. Now you can only see that one. If that negative is on the outside of the function, and in some textbooks they even move the negative over to the other side so that it's with the y. Okay? Again, I like my y by itself and the negative on the outside of the function. But can you see that you could multiply both sides by a -1 to get that second equation? Okay? So if that negative is on the outside of the function, this is a vertical reflection. Everything outside affects the y values. We're going to call this a vertical reflection. That's over your x-axis. And what happens mathematically to individual points is that your y values get multiplied by -1. Okay, I wanted this in front. So, oh, look at this cheating. Nice. Okay, sorry, wait for it. There you go. So if that negative's on the outside of your function, it's affecting your y values. You're going to multiply your y values by a -1. So if I had a point on my original graph, just estimating here, maybe this is 8, 4. If your y values are getting multiplied by a -1, can you see that the corresponding point would be here when it gets reflected over? The x is still 8, but now you have 8, -4. So we can find out what happens to the whole graph being reflected over the x-axis, but we can also think about a specific point that 8, 4 gets flipped down, it will become 8, -4. And all that's happening is your y values are getting multiplied by a -1. So now we're going to look at what happens if the negative's inside the brackets. Okay? That's going to affect your x values. You never had this with a parabola. Why did you never have this with a parabola? If you put it inside the brackets and square it, what does that negative do? Just disappears. So it's like we could have decided in grade 11 we're going to teach a whole lesson that doesn't actually matter because it doesn't actually affect it, right? Because that negative would disappear. But if the parabola was moved over here and you multiplied it by a negative, the whole thing gets reflected over the y-axis. Okay? So we can write similar notes that we had here before, that if the negative is inside the function, it's with the x. And in this one, you wouldn't be able to move that negative to the other side of your equation because it's inside your function. Then this is a horizontal reflection. You're going over the y-axis. And now all that's happening are your x values are getting multiplied by a -1. So if we go back up to look at our original graph, what's going to happen to 8, 4? Okay. Careful here, because you might be tempted to put it in either of these places. Does it make sense that it would be all the way over to that one? And you would be at -8, 4, because your x value would be multiplied by a -1. So because we had extra notes on this one, I included this as part of the video that's going to be part of example 1's video. Now, something that you need to know about me is that I do get excited about the next math question, okay? And sometimes when I get excited about the next math question, I go and flip this, like, here, we're on to example 1. Did anybody not finish writing any of that stuff? Yes. So that's going to happen a lot. And you have to just say, Mr. JR, can you go back just for a second so that I can finish up, right? Not a problem. But it's going to happen. I know it. So you just have to say, can you go back, please? Example 1. Here is the graph of g of x. It's just some random graph. We don't even know what equation it would be. Sketch the image after a reflection in the y-axis. So a reflection in the y-axis, that's a horizontal reflection, okay? Whenever you see which type of reflection it is, you should think about all the different ways that they could say a reflection in the y-axis. It's a horizontal reflection. That would be another way. So maybe we write above here, horizontal reflection. If it's a horizontal reflection, your x values are changing. In function notation, that would mean that the negative is inside with the x. And sometimes they don't tell you the y-axis. They would just say a reflection over the line x equals 0. That one I think is the one that is the biggest chances that you get the wrong value, right? X equals 0 is a vertical line, even though it has an x in it. And if you're reflecting over a vertical line, you have a horizontal reflection. So you can see all of these things are triggering the wrong kind of idea. So you've got x equals 0 is a vertical line, but that means it's a horizontal reflection. And it's your x values that are changing. So if I took a point like this one here at -3, 1, when I multiply the x by a negative, it's going to be at 3, 1. And if I took a second point here, -1, -2, when I multiply the x by a negative, I get 1, -2. Now, chances are if you're doing this question, you're not going to label all of those points. I just wanted to point out that you could multiply your x values by a negative. You would probably just go, okay, this one's getting reflected 3, so it'll be here at -3. And here, this one at 5, so -5. And then you connect the dot, which is so much fun. And you get your graph. Okay? So I read the question again. I read the sentence that I just did, sketch the image graph. Good. I didn't miss anything in that sentence. Then state the domain and range of each function. Okay, so it's important to read right to the end because you might not see that each function and just do one of them. So for our original function, the domain and range, and I'm going to use just interval notation in this question. Domain, to do your domain, your x values, think about what's the smallest x value. So coming from the left, the smallest x value is -3. And then it includes all of the x values until you get to 5. For the range, the smallest y value coming from the bottom is -2. Then it includes all the y values until you get to +2. Then for my green graph, domain and range, now my smallest x value is -5. My largest x value is +3. In my range, my smallest y value is -2, and my largest y value is +2. Again, we got the domain and range because we had the graphs. If they didn't give you the graph, but gave you the red domain and range, could you have gotten the green domain and range in this question? Does it make sense that the range didn't change? Why? The only thing that's happening is you're multiplying x by a -1. So your y's are not changing. So your range didn't change. Can you see how multiplying x by -1 would have changed the domain from this to this? If you multiplied each of those values by a -1, you would get +3 and -5. Interval notation, we're always writing the smallest value first because it's an interval from smallest to biggest. So does it make sense that that would be your new domain? So what happens in your questions, these questions, just because we've done this one, it opens up a whole bunch of different ways that you could ask a question. And so doing one example means you should now be able to do a bunch of different ones, even if they're not exactly the same. Okay. Questions 3 and 13. Read the question over one last time, make sure I answered everything. I did.